have a look at 14H. 14H, this is the skill where you're applying how to find or how to solve a circular functions equations. Kind of like what you did with logarithmic equations and exponential. You learned the rules and then you solved, right? The same thing here. We've learned all the rules just now, learned all the theory in terms of what a unit circle is. Now you're applying. You're trying to solve a problem like this one. So this is a generic one, a very simple idea. Now, one of the things about sine theta, which is different to quadratics, cubics, exponentials, and logs, is that there are infinitely many answers. Okay, you can have an infinite amount of answers. So just to get you to understand, this is your function right there, sine theta. So they're really just saying, if you had a function y equals sine of theta, theta is the angle. So I don't know what the angle is. And they're asking, when is the y value equal to half, right? Normally, if you had a graph, say 2 to the x, and you ask, when does it equal to half? You're essentially asking that point. That's what you're finding. You're finding 1 point. But in a sine graph, there are infinitely many answers because, and I'm going to sketch it for you to see, on your CAS here, I'm just going to clear that. I'm going to do control page, add a graph. Let's see what sine of x, or x being theta. You see how this is a sinusoidal wave is what we call them, but that's a wave, and it's an infinite wave. So I can keep zooming out, and it'll always be an infinite wave. So when you ask the question, you say, when does sine, so this graph, when does this graph equal to half? Half is the y value. So where on this x-axis, where is it half? That's 0.5. So half is right here. I've got this point to equal to half. I've got this point that equals half. There are infinitely many. This is what confuses students because they're used to seeing 1 answer, 2 answers, 3 answers, but never infinitely many answers. So this is what it looks like graphically. You're asking, when is that graph equal to half? That red line that you see, that's where half is. This is at this point on the graph, I have y equals half. This point on the graph, I have y equals half. At this point on the graph, I have y equals half. Your job is to find half, which one of those values, so which x-axis values, which x values or what angles will give you half between 0 and 4 pi. Okay? So, this sounds really complicated, but it isn't. Because we're going to use our unit circle to understand this. So I'm going to use my unit circle. Here we go. Let's have a think. Here's my unit circle. When you do 1 revolution, starting from 0, which is over here, when you do 1 revolution, what's the distance again? 360 degrees, but distance, which is radians. 2 pi. So this is 2 pi. But they're asking me to go from 0 to 4 pi. So that implies I'm going to move another revolution. So I'm going to go around the circle again, the second time, and then I land at 4 pi. Okay, so they're saying when you move around the unit circle twice, 2 revolutions, when will the y value, so this is the y value, when is the y value equal to half? You see the y values, we know that a maximum y value on the y-axis is what again? What's the maximum y value you can have? 1. What's the minimum y value? Minus 1. So down here is negative 1. So where is half? Half has to be the middle, which is these 2 points on the circle. So you only got that. So what they're trying to teach you here is that from 0 to 4 pi, you're doing 2 revolutions. How long does it take? What angle should it be to get half? Okay, so this is what I want you to think about. Here we go. Listening. Think about, I'm going to draw the circle again. We're going to start off at 0. So starting off at 0, when I move up, can you see I hit half? This is when the point x, I don't know what x is, but I know the angle, so whatever the angle is, I know the y value is half. The question is, using your exact values, this is why you needed to memorize it, what angle will give you a height of half? So go through your exact values again. If you have your tables or the way you can think about it, sine, which is the y values, sine of what angle Sine of what angle will give you half? Not 60 degrees. Cos of 60 is half. 30 degrees. So, your first answer, your first potential answer is, so I'm going to write it again for you to see. Sine of what angle to equal to half? The way you would do it is, this is what we're doing. We're going to get rid of the sine by doing sine inverse the left, sine inverse the right. You will now have theta is equivalent to sine inverse of half, but we know there are infinitely many answers. See, if you try this on your CAS, watch what happens. If I try this on my CAS, you're not going to get an answer. This is why students get confused here. So if I go sine inverse of half, which is 0.5, right? Watch. Oh, that's weird. Wait, is it sine inverse of half? Oh, no, so sorry. It's solve sine of x equals to half, and you want to solve for x. Okay, so you want to solve for x is what you normally do, but if I press enter, can you see it comes up with a disgusting answer? But not only that, they also give you n1. The reason why it's n1 is because there's so many possible answers, they've given you a rule. Whatever n is, that's the number of cycles that you have to go through to get those answers. So you can't do it on a CAS yet. I'll teach you how to do it on a CAS later. But we know, based on our calculations, the first point that will equal to half is right here. This is when, right there, that's the first one, and we knew the first one was 30 degrees, or pi and 6. So the first one is pi and 6, or I'll write it again, 0. You start off at 0, and you went up by pi and 6, because we know sine of pi and 6 will give you half. This is where you now use symmetry properties. If I went all the way across, this now gives me pi, but remember, I need to go back 30 degrees to get to that height, or to that point. This is the point that you have a y value of half. So you're going back minus by pi and 6. Can you see what we're doing? So here I'm saying you start off at, you end up at pi, but I've passed the point I really wanted, which was go back by minus pi and 6. That gives me my second solution. From there, I then continue around the circle, but I'm not getting half. The y values are all negative here. I want it to be half. So none of this will actually be any of interest for me. So I end up at now 2 pi. So I've done one revolution. And in one revolution, I have 2 possible answers here. Then you still have to do another revolution because it says 0 to 4 pi. So when I do that, I do it again. So on my graph, I delete all this just to make it easier to see. So I'm now at 2 pi. So this is now 2 pi, not 0 anymore. And I do another revolution. So from 2 pi, I go up and I hit my next solution. But I know it has to be an extra pi on 6. So here, I write 2 pi with an extra pi on 6. Then I go around all the way to this side now. That's now 3 pi. But I passed my solution again. The solution was there. I just went over a bit. So I have to now do 3 pi, subtract pi and 6. I got to go back pi and 6 amount to get to that point. And that's it. Once I go from 3 pi, I go all the way to 4 pi. There's no more solutions I'm interested in. These are my 4 answers. I have 0 plus pi and 6, which is pi and 6. I have pi minus pi and 6, which is 5 pi and 6. I have 2 pi plus pi and 6, which is 13 pi and 6. And then 18 minus 1, 17 pi and 6. So you can see what I mean. Why students find this hard. 1, you get multiple answers. 2, we're working with fractions. 3, we're dealing with radians and not degrees. This is why students find this exercise that I'm just showing you right now. This is one of the most preliminary types of approach that you need to go through. Okay, so we haven't even gone to what's hard, meaning like translations and vertical translations, dilations. We haven't done any of that. This is just a simple sine theta equals half, which is what makes this hard. Okay, so I'm going to just show you how would you do this on a CAS, because I want you to practice testing on a CAS as well. So notice the problem before on a CAS. This couldn't solve it. The reason why it can't solve because they're an infinite domain. But if you tell it to solve it between 0 and 4 pi, it will be able to solve it for you. Okay, so I'm going to do it on the CAS to show you how do you do a defined domain. I'm just going to make sure my mode is not in the further, because when I teach in further we use approximate, but in methods you should make sure your mode is in not in auto but in exact. All right, here we go. If I do the same thing again, I want you to do solve sine of x equals to 0.5 comma x. The only extra difference to get an answer is you have to put in a domain. So here we do control equals. You got a given line. So you say, I want you to solve given. So I'm going to put the given line. Given that it is between 0, x is between 0, so greater than or equal to 0, but less than or equal to 4 pi. So here, when I do that now, I'll do exactly the same line as I had up here. The difference was I'm now telling it, given you've got this domain. The calculator will know that I'm only going to solve between 0 to 4 pi instead of an infinite domain. So because of that, you only have limited amounts of solving to do. So hence, when I press enter, I get the same answers that I got manually. So manually I had pi and 6, 5 pi and 6, 13 pi and 6, and 17 pi and 6. And notice it's in its order. Because what the calculator is doing what we just did. We went through the unit circle 2 times, and in those 2 revolutions, we crossed it 4 times. We crossed once, twice, 3 times, 4 times. So if you use the unit circle and really try to understand it's using exact values, symmetry properties, then this makes a lot of sense. But it's this part that students struggle with. Okay, so students find this the hardest, and adding and subtracting fractions, that's what makes it hard. Okay, but theoretically, you're just moving around the unit circle. That's all it is. Yes?
Is there a way to write, like, say if we're doing this movement, is there like a way to write the movement changes for it instead? And would we be required to find that?
You mean this one?
Or do you mean like the general formula? Like here, like the difference is 4 pi and 6.
4 pi and 6.
Like you're adding 4 pi and 6 for every intercept.
Ah, so
like that increment, would you like just say this is the increment starting from here all the way to infinity? But it's not the same.
This is a very good question, because what you're asking now is exercise 14n. That's general solutions. So what you're asking is, what if I don't have a domain? Can I write something to talk about the increments? You can. So you can write this as, so for this point over here, I know this might confuse some of you here, but what he's asking is, if I know this is the point of solution for only one revolution, right? That means I can do another revolution and still land the same spot. I can do another revolution and still land at the same spot. So there has to be a better way of summarizing that, and there is. There is a way to say, well, actually the answers, we know pi and 6 was the first one, that was this point over here. You can actually just say, well, take pi and 6 as your first solution and add on 1 revolution. Now, how long does it take to go 1 revolution again?
2 pi.
2 pi, that's the distance. So I can actually say, add on 2 pi and n, and this is in exercise 14n, they say let n equal to z, meaning integers, and all that just means is n is the number of cycles. If you do 2 cycles, that'll be 2. If you do 1 cycle, that'll be 1. If it's 3 cycles, that'll be 3. So that means you're adding on 2 pi once, twice, 3 times, 4 times, but this should summarize all of the solutions from pi and 6 to get to the next one. We just add 2 pi from this one to the next one, and another 2 pi, and you can get all those answers from there. So you can see here, if I go back to my CAS, if I just did pi, whoops, that's not pi over 6 plus 2 pi, sorry, let me just fix that. Pi over 6 plus 2 pi, you can see here that gives you 13 pi and 6. So if you want to find the next one, you can literally say take that one plus another 2 pi, and you will get your next one. And you can keep adding 2 pi continuously and you get all the possible solutions for this point. But then you can also do the same for that one there, which is the second one. 5 pi and 6, and you write plus 2 pi. That will summarize all the possible solutions for this question. That's called 14n. That's exercise 14n, which absolutely bonkers a lot of students on that general rule. But that's essentially what you're asking. You're asking, is there a way to write those increments? And there is. There is a summary on how to get that answer there. So you are meant to write, theta will equal to, that's one possible solution. And then you'll do the second one, which is 5 pi on 6 plus 2 pi n, where n is an element of z. That's when it gets confusing. Okay, but to do that, you have to start off by understanding this step. Okay, so that's what I'd want you to train to do. We're going to do one more example just to get you to get a feel of how to find the solutions. Okay, so I'm going to go down now. Let's go. Let's find this one. Here we go. Let's do one more, and I'll give you your time to have a think, okay? So here we go. Let's do a cos version. Let's do cos. So example 19, you've got cos of an angle is equal to root 3 on 2. Okay? Same thing. You want to find theta, do cos inverse both sides. This is what you're trying to figure out. Cos inverse of root 3 on 2. Draw the unit circle. So a lot of kids will get here and they're like, I don't know what I'm doing. Draw the unit circle. Okay? Let's think about a unit circle. That's my unit circle. They told me that I'm going from 0 degrees to 360 degrees. How many revolutions is that? 1. Very good. So I'm only going from 0 all the way to 2 pi. That's my distance. I'm only going 1 nice revolution. My next part of the question, and my pen just died, by the way, so I'm going to use texters now. I know. Good old whiteboard markers going on here. Here we go. So we are going to go from 0 all the way to 2 pi. That's 1 revolution. But we want to know how many times do we cross when cos equals root 3 on 2. Now cos is the x values. We know the maximum x value is 1. We know the minimum x value is -1. So where is root 3 on 2? I don't know what that is. All I know is root 3 on 2 is the positive side. It's not negative. So say it's over here. If that's root 3 on 2, where on the unit circle will have an x value? It could be here. That's where root 3, when x is root 3 on 2, I don't know what the y value is. Or down here. These are the only 2 spots where the x can be root 3 on 2. Right? So this is my angle. From here to here, that's an angle. And then from here to here is the same angle. Okay, so I've got 2 points. Now to solve it. How do we solve it? You go around the unit circle starting from 0. And start at 0 and you're going up, 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 and hit your first solution. Question is, in this triangle here, what angle should it be? Going through your exact values, cos of what angle will give you root 3 on 2? So go through your exact values, cos of what angle will equal to root 3 on 2? What was that? Pi on 6, which is 30 degrees. So I know, going through my exact values, it had to be 30 degrees. That means this distance here had to be pi on 6. So my first solution to answer this question, I knew I started off 0 and I need to move up 30 degrees or pi on 6. So my first answer is 0 plus an extra distance of pi on 6. That will give me my first solution. Then I move around the circle, I've got my first solution, I keep going and going, I'm still not getting any root 3s on 2s until I reach here. But I know I'm almost to the end. I'm almost at 2 pi. I'm just missing this angle here. Now that angle there, to get root 3 on 2 distance, we knew this angle had to be 30 degrees. That means this distance from here to here that I need, I'm missing pi on 6. So that means I can start off here and say, well, let's say I go all the way down to 2 pi, but to get back to my solution, I have to subtract pi pi 6. I have to go backwards. So my solution here, my next one would then be go all the way to 2 pi, and then come back through a distance of pi 6. And that should cover this solution at that point. So 2 pi's here, I minus pi 6 to get back here. And also from here, we started at 0 and we added pi 6 to get there. And that's one full revolution. So in one revolution, I will cross when cos will equal to root 3 on 2 twice. It'll be 1, 2, and then I finish. So I get 2 possible answers there. And so to summarize your answer, 0 plus pi 6, pi 6, 2 pi minus pi 6, which is 11 pi 6. That's in terms of radians. You can work in terms of degrees. This would be 30 degrees. All the way is 360. But since you're subtracting pi 6, that's subtracting 30. So 360 minus 30, 330 degrees. And that is my solution in terms of degrees, or if they want in radians. So I can do that on my CAS. So if I show you on my CAS here, let's try now CAS. I'm going to clear this out again. You're doing menu 3, 1, so I'm solving. What am I solving for? Cos of x is equal to root 3 on 2, so root 3 on 2, comma x. But remember, if you just press enter, it's not going to come out an answer. You need to give it a domain. So I'm going to give you a domain. Control equals given, and here we go. From 0 degrees, so 0 is greater than or equal to, so x is greater than or equal to 2 pi. And notice that my mode is in radians. If your mode is not in radians, it's not going to work. Okay, so my mode's in radians. If I press enter, I get pi 6, and I get 11 pi 6, which is what we had over here. If I changed it to degrees, okay, so if I went to documents, go to settings, document settings, and I change radian angle into degrees, then what you can expect is, whoops, sorry, we have to change the angle to 0 to 360. There we go. You get 30 and 330. Okay, so it depends on what you want. Do you want it in degrees or do you want it in radians? That's what you can do. But I need you to first understand how you're moving around the unit circle. If you can get just this step, that bit, that's the most important part. Okay, the calculation from 0 to pi 6 or 2 pi to minus pi 6, that's symmetry properties. So I've broken it up for you there. We did exact values, what angle, then we did symmetry properties, and we're tying it in together because all you're doing is you're solving. When is this function? You've got a root 3 on 2. Okay? So later on you'll find that as you're doing the graphing, you're solving for the x-axis intercept. You're going through the same motions. So the first step is you have to understand 14E, 14F. Then when you do 14H, it should be okay, technically. Right? So I'm going to start the video.